Hi, this is Sajjad, welcoming you to this video of Nuke Learning. Utility nodes deal with stereoscopic or multi-view compositing. Anaglyph. If you're working on a stereoscopic or multi-view project, you can use this node to convert your input into an anaglyph image. Join views. If you have separate files for the views that exist in your project settings, Join Views lets you combine these files into a single output. Mix Views. If you're working on a stereoscopic or multi-view project, you can use this node to display a blend between two views in the viewer. One view lets you separate one view for processing. This is useful if you need to perform different actions on different views. Reconverge. If you're working on a stereoscopic or multi-view project, the Reconverge node lets you shift convergence so that any selected point in the image appears at screen depth when viewed with 3D glasses. This point is called the convergence point. Shuffle views. You can use this node to rearrange the views in your script. Side by side. If you're working on a stereoscopic or multi-view project, you can use this node to display two views next to each other in the viewer. Split and Join is a combination of one view and Join Views nodes. It allows you to extract all the views in your project settings, process them individually, and then merge them back together. Metadata nodes deal with information embedded in your images, such as the image's original bit depth, width, and height. Add timecode adds a timecode to the metadata passed down from an input node. Compare metadata. Connecting nodes to the Compare Metadata node enables you to quickly determine metadata differences between files. Copy metadata. This node copies metadata from one image to another, filtering the metadata to exclude some keys if required. The Modify Metadata node enables you to add, edit, or remove the metadata associated with a file. View Metadata lets you inspect metadata, such as the image's original bit, depth, width, and height, passed down by an input node. Toolsets deal with custom tools created in Nuke. You can create your own toolsets from scratch or modify the existing 2D and 3D examples that ship with Nuke. The example scripts also contain a link to footage you can download to use with the examples. Nuke ships with the following 2D toolsets: TBCG Beauty, a basic approach to splitting out and merging back together several layers from multi-channel EXRs using some common third-party renderers such as Arnold, Modo, and RenderMan. You can load this toolset from here. Keying, TK Keying, an example of combining different keys from blue or green screen footage to produce a better matte. This toolset creates a key for the edges of the alpha channel, ignoring fine detail, and then combines it with a hard, core matte. Finally, the edges are keyed separately, masked, and combined with the result. You can load this toolset from here. TSV Smart Vector Fix, an example of rendering vectors for a plate and then using Vector Distort to warp the source. You can load this toolset from here. TSV Smart Vector Grade, an example of rendering vectors for a plate and then using Vector Distort to warp a black and white mask over the source. The warped mask is then used to grade the original plate. You can load this toolset from here. TSV Smart Vector ST-Map, an example of writing the results of a smart vector to disk as an ST-Map sequence to save processing time. This ST-Map can then be used throughout the shot as needed rather than recalculating the warp. You can load this toolset from here. 3D toolsets, Nuke ships with the following 3D toolsets. Particles, P-Dust Hit, creates an adjustable dust particle system. P-Fogbox creates an adjustable fog particle system. P-Snow Rain creates an adjustable snow or rain particle system. P-Sparks creates an adjustable trail of sparks. P-Trail creates an adjustable comet effect. TP-R Clean Project, an example showing painting out the rig on a single frame, projecting the paint onto 3D geometry and rendering it through the moving scene camera, and then merging the correction back over the source plate. TP-R Clean Texture, an example showing projecting a single frame through a static camera onto geometry, unprojecting that frame to the geometry's UV space to remove perspective, painting the correction and reapplying it to the geometry through the moving scene camera. The correction is then merged back over the source plate. TP-R Existing Project, an example showing projecting an existing clean frame through a camera onto 3D geometry, rendering it through the moving scene camera, and then merging the correction back over the source plate. TP-R Exiting Texture, an example applying a pre-existing clean texture to 3D geometry, rendering it through the moving scene camera, and then merging the texture back over the source plate. TP-R Planar Track, an example showing creating a cleaned frame using a Roto Paint node, tracking a plane using the Roto node's tracking tab, and then using the resultant corner pin node to track this frame into place across the entire sequence. TR Relighting, an example script showing the creation of a point cloud from a position pass, which is then used to relight the 2D image from 3D light information. Other nodes contain additional nodes for script and viewer management. Assert. You can use this node to test the validity of a TCL expression. If the expression resolves to false, this node raises an error. Audio Read. You can use this node to read in an audio file and view it in the curve editor and dope sheet to line up keyframes of your composition with the waveform of the sound. Backdrop. This node visually groups nodes in the node graph. Inserting a backdrop node creates a box behind the nodes. When you move the box, all the nodes that overlap the box are moved too. The Blink script node runs Foundry's Blink framework, enabling us to write our code once and run it on any supported device. This is achieved through code translation, in which the Blink code is turned into specific code for each target device. Code is generated and compiled on the fly, allowing you to switch between devices at will. The Burn-in node allows you to add text to certain areas of your footage quickly without relying on the text node. Disk cache caches to disk scan lines from its input as they are requested by its output. It does this at full 32-bit floating point. This allows Nuke to reference the cached data instead of constantly recalculating the output of the preceding nodes. You can use the dot node to make bends in the connecting arrows between other nodes. This can help you keep your script easy to read. You can use the group node to nest multiple nodes inside a single node. The original nodes are replaced with the group node. When you create a group node, its internal structure is shown in a separate node graph that opens. Input adds an input arrow to a group node. This allows you to add multiple inputs to your group or gizmo. Live group nodes can be used in conjunction with live input nodes so that multiple artists can work on different parts of the same shot as separate scripts without the need for rendering. No op passes the input image through unchanged. It does not alter the image in any way, but can be used as an interface for controlling other nodes. Output adds an output arrow to a group node. This is necessary if the node tree that forms the group has several branches and thus several possible output nodes. Postage stamp. You can add this node to your script to display a thumbnail render of the output at the current frame or a frame of your choice. This node does not alter the input image in any way. The pre-comp node is like a group node, but its content is stored in an independent NK file. This allows you to save a subset of the node tree as a separate Nuke script, render the output of this saved script, and read the rendered output back into the main comp as a single image input. Sticky Note lets you add notes to the node graph. All plugins. This menu contains all nodes available in Nuke, including any unsupported nodes. Plugin nodes. Furnace core nodes contain the most popular Furnace plugins incorporated in Nuke X and Nuke Studio. F-Align takes two sequences that were shot of the same scene and lines them up spatially. F-Deflicker 2 is used to remove flicker. F-Regrain is used to add grain to a sequence. F-Rig removal eliminates unwanted objects, or rigs, from image sequences without the need for accurate rotoscoping or keying to produce a clean plate. F-Steadiness uses global motion estimation to calculate a four-corner pin so that camera motion within a single shot can be smoothed out over a range of frames or removed by locking to a specific frame. F-Wire removal is particularly good at removing wires over heavily motion-blurred backgrounds or wires over smoke, dust, or clouds. It can be used to remove each wire in a sequence or to quickly create a clean plate, which can then be tracked into place. Kara VR makes it easy for artists to use Nuke's full suite of compositing tools on 360-degree footage for cleanup, set extensions, 3D element insertion, and more. Katana is a look development and lighting powerhouse that tackles creative challenges with ferocity and ease. It arms artists with the creative freedom and scalability to exceed the needs of today's most demanding CG rendering projects. These nodes are not available by default and must be imported from an installation of Katana. Ocular is a unique and powerful collection of 16 workflow plugin tools for Nuke that help take the headache out of stereo post-production. Ocular nodes are only available if you have an Ocular license for Nuke. Air nodes are machine learning tools designed to assist artists with some of the heavy lifting in VFX work. Cat File Creator gives you the ability to create your own custom .cat files from within Nuke. It also allows you to attach user knobs to your .cat files so that you can have complete control over your machine learning models via the inference node. Copycat copies sequence-specific effects, such as garbage matte, beauty repairs, or de-blurring from a small number of frames in a sequence and then trains a network to replicate this effect on the full sequence. Copycat outputs a trained network in a .cat file ready for the inference node to apply your effect. The de-blur node attempts to remove motion blur from the input image using a pre-trained machine learning network. The upscale node increases the input format by a factor of 2 using a pre-trained machine learning network. The inference node applies a cat file supplied by the copycat node to create the effect modeled by the network across the input image.